Number 4, they throw this bowling pin up and they ask you what happened to the maximum height. So they're giving the answer choices are they're not quantitative here, right? So we're looking for an expression using variables. So if you know that you have to use this equation because you're given the initial velocity at which it's thrown, at maximum height, you know that final velocity is 0. You know the acceleration is equal to g. And you want to know the displacement or the maximum height, you're going to use this equation. We know that the final is 0. So if I rearrange this to get d here by itself, I get v initial squared over 2g. And the negative, because acceleration due to gravity is negative, the negatives cancel and you don't have to worry about that. Now, some of these answers here, you don't need to know time. We have other equations besides some of them with time. And it says an irregularly shaped object is too complex to treat as a single point mass. That's not true. You can treat the center of mass the same way. It moves just like a point mass does. In number 5, it asks you to find at 2.5 seconds. Here you want to know the position, and we know that this object starts at, so here's our number line, so the object is going to start at 0 here, and we can see that it's slowing down as it's moving. So it's slowing down until it gets to, it's at rest. So at some point here it comes to rest. This is at 1.5 seconds. And then here it's turning around and returning, right? So it's increasing speed backwards. So slowing down, acceleration is negative, it's speeding up. Acceleration is still negative, that's why it's a straight line. So the measurements stop at 2.5 seconds. Now I think you can see that these areas are unequal, right? This area, which is positive, and this area, which is negative, this area is smaller. So it's not gonna get all the way back to this position. Now at these times, this position, this initial position is 0.5 meters. So it does not get back to 0.5 meters. Okay, so all we need to do is find out how far it went, and then we can do this quantitatively. So I'm going to find the area that's positive. I'm going to do 1/2 times the base, which is about 1.5 seconds, times the height, which is 3 seconds. So that gives me 1.125 meters. So add that to 0.5 meters and you get 1.625. So that's somewhere over at here, 1.625 meters away. Then this is going to subtract from it. So now before you go and do that, look at these choices. We know it doesn't get all the way back. We know it doesn't even reach 1.75. So it's got to be this one. There's no way it reached 2 meters. So using process of elimination, you don't even have to finish this problem. Numbers 6 and 7 are open-ended, so we're going to skip that for now. And we're going to look at this problem here. This 2-block object is spinning while it's traveling. And so one thing you have to know is same thing with the bowling pin, is that an irregularly shaped object rotates about its center of mass as if it's a point mass. And you can see that because this graph of velocity versus time has a steady acceleration. If it was lopsided or wasn't moving in a straight line, you would see an acceleration that was not constant. So on number 8, they're saying which of the following claims are correct about the system, and you're going to select 2 of these answers. The total displacement of an individual block is 0 because it travels in a perfect circle. So that's not true because it's also moving in a straight line, right? That's what this direction of travel says. So this is not true. The acceleration is constant. Well, we know that's true because we have a steady slope on a velocity time graph. the change in velocity per time for this system changes. No, that's not true, because change in velocity over time is acceleration, and we just said the acceleration is constant. Oops. And last, the system's acceleration is opposite the direction of the velocity system. Well, if acceleration is one way and velocity is the other, that means decreasing speed. And I can see that this is going to be decreasing speed because it's going to have a negative acceleration. It's got to be opposite the positive direction, because they tell you that it moves in the positive direction. So that's correct also. So